Hello dear students, welcome back to online classes on data communication. So today's topic is wavelength division multiplexing. As you all know, we have learned in the last video about frequency division multiplexing, its uses, its working principle, and we have solved some problems on it. So in this video we are going to cover wavelength division multiplexing. What is it and what are its uses and its working principle we are going to see in this video. So first of all, what is wavelength division multiplexing? Wavelength division multiplexing, or we call it as WDM in short, has been the technology of choice for transporting large amount of data between sites. Whenever you are required to send a huge amount of data between two different sites, working sites, then we usually use WDM. It increases bandwidth by allowing different data streams to be sent simultaneously over a single optical fiber network. That is its main use. In this way, WDM maximizes the usefulness of fiber and helps optimize network investments. So traditionally, WDM systems have been adopted by carriers and service providers. Large-scale systems designed for national infrastructures made the systems prohibitively expensive and too complex for private network use. That is one of its disadvantage. So the foundation of WDM lies in the ability to send different data types over fiber network in the form of light. By allowing different light channels, each with a unique wavelength, to be sent simultaneously over an optical fiber network, a single virtual fiber network is created. Instead of using multiple fibers for each and every service, a single fiber can be shared for several services. In this way, WDM increases the bandwidth and maximizes the usefulness of fiber. Fiber rental or purchase represents a significant share of networking costs. That is one of the added advantage with this. So using an existing fiber to transport multiple traffic channels can generate substantial savings to an infrastructure. So that is one of the use of WDM. So wavelength division multiplexing, as you all know, is designed to use high data rate capability of fiber optic cable. So we are using fiber optic cables here to send and receive data. So one of the technique we are using along with it is WDM. Then the optical fiber data rate is higher than the data rate of metallic transmission cable. This you all know. So in optical fiber cable, we will send data using light as a medium, but using a fiber optic cable for a single line wastes the available bandwidth. So what our need is, we need to utilize the bandwidth. We need to make maximum use of the bandwidth. So one of the technique we are using here is multiplexing. So multiplexing allows us to combine several lines into one. As you all know, in the previous method, that is in FDM, we have already discussed this. What multiplexing does, it allows us to combine several lines into one. So in this multiplexing technique, what we are doing is, we are sending several light sources. Light sources means these sources have different wavelengths, lambda 1, lambda 2, lambda 3. I'll discuss it with a figure there in the next slide. So again, we are multiplexing these light sources, and we are creating a single line or single light source, which we will send it through a optical fiber cable, and at the other end we will do demultiplexing, and we differentiate these lambda 1, lambda 2, lambda 3 what we have sent from the source side. So we will discuss this in deep. So the idea here is the same. We are combining different signals of different frequencies. So in the FDM, what we have done is, we have combined different signals which have different frequencies. There we have combined with different frequencies. Here we are combining with the signals with different that is the wavelength. WDM is conceptually the same as FDM, as you all know. So except that the multiplexing and demultiplexing involve only optical signals. There we have involved analog signals, and here we are involving optical signals which are transmitted through fiber optic channels. So the idea is the same. We are combining different signals of different frequencies. The difference is that frequencies are very high here. Then this figure conceptually represents wavelength division multiplexing. So here we have a WDM multiplexer and a demultiplexer. You can see here. I'll mark it. We have a WDM multiplexer and we have a WDM demultiplexer. Very narrow bands of light from different sources are combined to make a wider band. So these are lights from different bands, lambda 1, lambda 2, lambda 3. These are the lights from different sources. They are combined to make a wider band. This is the result of combination of all these lines, lambda 1, lambda 2, lambda 3, and thus we have created a wider band of light. And at the receiver end, this is receiver end, the signals are separated by a demultiplexer, and as you all know, see the results, they are separated again into lambda 1, lambda 2 and lambda 3. So at the receiver, the signals are separated by demultiplexer. Although WDM technology is very complex, the basic idea is very simple. We want to combine multiple light sources into one single light at the multiplexer and do the reverse at the demultiplexer. So the combining and splitting of the light sources are easily handled by a prism. We can see in this figure. Combining and splitting of light sources are easily handled by a prism. This we have learnt in physics. So recall from the basic physics that a prism bends a beam of light based on the angle of incidence and the frequency. So using this technique, a multiplexer can be made to combine. This is multiplexer. A multiplexer can be made to combine several input beams of light. These are several input beams of lights, each containing a narrow band of frequencies, into one output beam. This is one output beam of a wider band of frequencies, and the work of demultiplexer is to reverse this process. What the multiplexer has done, this prism will, which acts as demultiplexer, will do the reverse effect of the multiplexer. So one application of WDM is SONET. SONET means sonar area network, then in which multiple optical fiber lines are multiplexed and demultiplexed. So we discuss SONET in upcoming chapters. A new method called dense WDM, that is DWDM, which is used here in this slide. In the opening slide I have shown you. So this is DWDM, that is dense WDM. It is used to multiplex a very large number of channels by spacing channels very close to one another. So it achieves even greater efficiency than this WDM. We have two versions of WDM, that is coarse wavelength division multiplexing and dense wavelength division multiplexing. So this dense wavelength division multiplexing, it gives you a greater frequency. So this is all about wavelength division multiplexing. So the points to be noted here is this multiplexing and demultiplexing process, that is its working principle. The question may be asked as, explain wavelength division multiplexing and its working principle. So whatever I have discussed in this video, you have to write it in your answer. So this is all about wavelength division multiplexing. In the next video, I'm going to cover time division multiplexing and its uses and its working principle and some problems on TDM. So this is all in this video. Please comment in the comment box there. Shall I do a video on each concept or some 30 minutes long video together combining several concepts? Please tell me this. Thank you.